Hi everyone, welcome back to another ACT Math video. Today we're going to be going over the coordinate geometry content area, the fifth content area in the series. This is an important part of the ACT Math exam along with the other algebra parts and plane geometry. So it's very important that you understand the topics that are listed here as we're going to go through each one. So let's start with lines and slope, specifically slope-intercept form. So for lines, right, typically when we are graphing, right, let's say we have a line like this. We write lines in y equals mx plus b form. That's where we get the concept of slope. That's our m. So y is like our output, x is our input, b is our y-intercept, which is where the line intersects the y-axis, but m is our slope. So for example, if we were to use this line that I already have here, right, let's say we do 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, right? And if we were to label our axes, that's important, x and y. And let's say we want to find the slope-intercept form for this line. We can do that just by using 2 points. We have 0, 4 right here, and then we have 2, 0 right here. So to find the slope, we do the equation y2 minus y1 over x2 minus x1, where we can like call this point our x1, y1, and we can call this point here, draw that a little bit better, we can call this point here our x2, y2. So our slope would be 0 minus 4 over 2 minus 0. Right? Because y2 minus y1 over x2 minus x1. So I'm going to move the calculation up here so you guys can see it a little better. It'd be negative 4 over 2 or negative 2 as our slope. So we have y equals negative 2x plus our y-intercept. Where does it intersect the y-axis? Up here. So plus 4. So what the slope of negative 2 means is as we go to the right one, we're going down 2. So it's like down 2 to the right 1, down 2 to the right 1. Like this, basically. Okay? So that's the idea of slope, and that's how you do straight lines. You'll be given points, you'll be able to find the slope and then the y-intercept. Make sure if you're not given the y-intercept, you plug in a particular x and y value that they give you to find the y-intercept, and that's basically how you do slope as well. All right. Moving on to the next topic of parallel and perpendicular lines. So basically, when we graph parallel lines, they look like this. They have the same slope. Basically, that's the idea. So like, for example, these aren't reflective of these lines, but let's say we had like y is 2x and y is 2x plus 5. They both are parallel lines, meaning that they have the same slope, and more importantly, these lines are not going to intersect because they have the same slope. So they're going like this the entire time, for example. So they're not going to intersect at all. So that's important to know about parallel lines. Perpendicular lines, they're running at like a 90-degree angle to each other, right? So like we would have this and then maybe at a 90-degree angle like this, for example. The way to recognize perpendicular lines is that the slopes are going to be opposite reciprocals of each other. What does that mean? That means if we have, let's say we have a slope of 3x, the reciprocal of 3 is 1 over 3, and opposite meaning we change the sign, so it's going to be negative 1/3 x, for instance. That'd be an example of a perpendicular line. It's opposite reciprocal for its slope, and these will intersect, obviously at this one point, for example. So that's parallel and perpendicular lines. That's all you need to know about it. Remember, parallel lines, same slope, and they're not going to intersect. Perpendicular, opposite reciprocal slopes, they will intersect at a particular point. All right, moving on to graphing inequalities. So we talked a little bit about inequalities in an earlier video, but we're going to talk about how specifically to graph them now, and it's more than just the number line. Specifically, if we're given an inequality, we'll start off with a pretty easy one. Let's say y is greater than or equal to 2. So if I were to draw a graph, right, let's go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and label our axes. So the key to graphing these inequalities is you want to first treat it as if it's an equation to start with, right? So we can imagine this as like our y equals 2 line, because that's where our line is going to be. So like right here. So I'm going to go ahead and I'm going to draw a line here, because that's our y equals 2 line. And then now we want to throw the inequality sign into consideration. Here it's greater than or equal to. So that means it's including this line and what's above. So that means it's going to be everything that is above here. That would be, you'd be shading areas when it comes to graphing inequalities, and this upper area is what you'd be shading because our inequality is greater than or equal to 2. If it was just greater than by itself, so if we had like y is actually no, let's do y is less than 1. So again, you're finding that y equals 1 line, right? That'd be right here, right? But the difference is, instead of it being a solid line, it's going to be a dashed line at y equals 1. So it's going to be a dashed line like this. And since we're looking at what comes underneath 1, like is y less than 1, it's going to be all this area underneath here. That would be for y is less than 1. So this is a pretty simple example. Let's do one with an actual slope-intercept equation. So like let's say y is greater than 2x plus 1. So I'm going to once again graph and make sure to label my points. So 1, 2, 3, 4, 1, negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So again, I want to first treat this as if it's an equation. And since it is a greater than or equal to, it's going to be a solid line anyway, so you can like almost like do it as if it's an equation and then worry about the inequality part in a second. So when it comes to graphing lines, always start with your y-intercept to graph. So I'm going to start at 0, 1. That's where I want to graph first. And then I'm just going to follow slope, right? I'm going to go up 2 to the right 1. So this is a point up here, right? We would do it again, up 2 to the right 1. Oops, up 2 to the right 1. This would be another point. So then I can do it the opposite way, right? Down 2 to the left. Oops, sorry. Down 2 to the left 1. Down 2 to the left 1. So you can see we kind of have this line here, and I apologize, it's not the most straight line, but this would be our line. This is our equation, basically. Okay, I'll leave it there. Okay, so now that we have this equation, now the actual inequality part of the problem comes into play. So we want to find a way to shade the area that satisfies this inequality. So how would we be able to do it? You want to try test points that are not on this line. So for example, 0, 0. Does this line go through 0, 0? No, it does not. So let's try that as a test point for this inequality. So let's try 0, 0. So 0 is greater than or equal to 2 times 0 plus 1, which is going to be 0 is greater than or equal to 0 plus 1. 0 is greater than or equal to 1. Okay, is this true? No, it's not, because 0 is not greater than or equal to 1. So that means our shaded area is not going to contain 0, 0. So in this case, since we're only dealing with one line, it's pretty simple. It's just the other side that is not having 0, 0 on it, right? And if you really wanted to, you could try another point, like let's say 0, 4. 4 is greater than or equal to 2 times 0 plus 1. 4 is greater than or equal to 0 plus 1. 4 is greater than or equal to 1. Yes, that is true. 4 is greater than 1. That inequality is satisfied. So this left area, that's what you'd be shading. And then I want to really quickly work on a problem where you have like two different equations and you have to figure out like a common area to shade. That's also kind of a difficult problem. So just to make things nice for me, I'm going to make the equations kind of simple just to make things nice for me. But you'd follow the same process for any of these, by the way. So 1, 2, 3, 4, 5. 2, 3, 4, 5. All right. 2, 3, 4, 5. So what we're going to do is this. We're going to first graph this first inequality. We're first going to deal with this first inequality before we start worrying about the second inequality. And when I mean inequality, I mean we're also going to be thinking about shading areas with this first inequality before we even like move on to the second inequality. So again, let's start with our y-intercept of 2. So 0, 2. Up 1, right 1. Up 1, right 1. Oops. Up one, right one. Erase this little mark here. Okay. Up one, right one. Down one, left one. Down one, left one. Down one, left one. Oops, that should be here. Down one, left one. Down one, left one. So this line right here is x plus 2 to the best of my ability. All right. So we want to figure out the area that we're going to be shading here. We're not going to actually like put it on the graph. We're just going to kind of mentally remember it. Because remember, we're trying to find the area where both the inequalities are satisfied. But if we have a general idea of what area it's going to be, it can already help us eliminate some stuff. So here, if we try, again, we'll try 0, 0 for a point. 0 is greater than or equal to 0 plus 2. 0 is greater than or equal to 2. Okay, that's wrong. We know that's definitely not right. So it's going to be somewhere on this left side here. All right, we're not going to shade yet, remember, because we still need to graph the other inequality. But it's going to be somewhere on the left side of this line. Just try to remember that. All right, so now we're going to graph this one. Our y-intercept is 0. Oh my god, wow. Okay, let's try that again. Our y-intercept is 0. We're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, down 2 to the left 1, down 2 to the left 1. All right, so like this line right here is what we're dealing with. Okay, awesome. So this is actually going to be a dotted line. I should have thought about that before I put the line. It's going to be a dotted line, remember, because our inequality is less than or equal to. It's not, I'm sorry, it's less than, my bad. It's less than, it's not a less than or equal to, so that means we're going to have a dashed line. So we want to try a point. I'm actually going to change this to a greater than sign, actually, now that I think about it. Okay. So it's going to be actually y is greater than 2x. Sorry about that, guys. So we're now going to look at on the left side, right? Because this is what we were looking at. We said after this line, we want the left side. So now I'm going to try a point. Let's try 0, 5. So we have 5 is greater than 2 times 0. 5 is greater than 0. Yep, that works. So that means that this left side is going to be all the points. That's going to be all the points that you're going to have that is a solution to both inequalities. That's important. So that's the idea to do it for two inequalities. If you're given those, make sure you work at one inequality at a time. After you do the first inequality, have a general idea of where you're going to be shading, and then make sure you stick with that area for the second inequality so you get that specific area that is having solutions that are common to both inequalities. That's important. Okay, moving on to distance and midpoint formulas. So distance formula is basically a formula you need to remember. It would be x2 minus x1 squared plus y2 minus y1 squared. So you can find it between any 2 points. Like for example, let's say we have 2, 5 and 4, 9. So if we want to find the distance between them, if we call this our x1, our y1, this is our x2, our y2, we have 4 minus 2 squared plus 9 minus 5 squared. So our distance formula, we're going to have it as 2 squared plus 4 squared, because 4 minus 2 is 2, 9 minus 5 is 4. And we'd be left with square root of 4 plus 16, which is square root of 20, which we can simplify to square root of 4 times 5, or 2 root 5. So that would be the distance between both of these points. The midpoint formula, on the other hand, is a little different. So the midpoint is basically you're trying to find the midpoint between 2 points. So the midpoint formula would be x1 plus x2 over 2, comma y1 plus y2 over 2. This would help you find the exact midpoint, the exact coordinate that is in between two other points. So if we have 1, 5 and 6, 12, and we want to find the midpoint, right? I'm just going to call it M for right now. This is our x1, this is our y1, this is our x2, this is our y2. So 1 plus 6 divided by 2, 5 plus 12 divided by 2. So it would be 7 over 2 comma 17 over 2. So this is the point that is exactly halfway between these 2 points. So those are just formulas you need to remember. They're pretty easy to use though. Okay, next topic is circle graphs. So specifically, how do we graph circles? So before we do that, let's understand the formula for a circle. It's going to be x minus h squared plus y minus k squared equals r squared. This is actually the equation for a circle, my bad. Equation for a circle is this. So what does this represent? So this is our x coordinate. This is our y coordinate for our center of the circle. And then this r represents the radius. So if I have an equation, x minus 3 squared plus y minus 2 squared equals 4, that means that my center is going to be 3, comma 2. Remember, these negatives are part of the equation, so they're positive technically. 3, comma 2, that is my center. And my radius, remember this is r squared, so our radius is going to be the square root of 4, which would be 2. So that would be our radius. So then when it comes to actually like graphing this, right, if we have a, we're going to just use this equation. If we draw a graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5. These aren't 100% spaced correctly, but this is just to illustrate to you guys. When you're graphing circles, you want to start with the center. That's the point that you want to start at first. So 3, comma 2, we said that's the center here. So that's where we're going to start. We're going to put a little dot here to indicate this is the center. And then our radius, right? That's also important because our radius, that's going to tell us like the endpoints of the circle. So we're going to go like 2 right, 2 left, 2 up, 2 down, and then connect it. That will give us our circle. So 2 to the right of 3, comma 2 is 5, comma 2. 2 to the left of 3, comma 2 is 1, comma 2. 2 above 3, comma 2 is 3, comma 4. And then 2 below 3, comma 2 is 3, comma 0. So now we're just going to connect it in the best way that we can. So this would be, it's not 100% a circle, but I promise you guys, like, that's how you do it. That would be a circle. And it makes sense since our radius would be 2, for instance, in either direction. So that would be how you'd be able to graph a circle. And again, if you're given a graph and you're asked to write the equation, first look at the center and then look at the distance between the center to one of the endpoints. That will give you the radius. And remember, in the equation, it needs to be radius squared. So remember that. All right, moving on to the next topic of the vertical line test. So this is kind of an extension of functions that we talked about in an earlier video. Basically, for a function to be a function, it needs to pass the vertical line test, meaning that if we were to draw a vertical line, it should only pass through that graph one time. That's it. So if we have something like this, right? If we were to draw a vertical line literally anywhere, it should only touch this graph one time, which it does. It only touches the graph one time. So this would be an example of a function. An example of one that's not a function. Actually, no, that's a bad one. That is also a function. This one. Okay, you see how we're drawing vertical lines and it's touching 2 points here? Then it's not a function. A vertical line can only pass through the graph of a function one time. That's important to know. Okay, but that's basically all what this is about. All right, parabolas. So parabolas, they're usually in the equation y is ax squared plus bx plus c, right? They typically follow this U shape, right? Oh my god. Trying to draw y equals x squared, but that is not a good y equals x squared. All right, let us try again with this. All right. So you can actually touch. Okay. No, this is not good. All right, hold on. There we go. Finally, a good y equals x squared. So this is an example of a parabola y equals x squared. It's an upward facing one because it's y equals x squared. The a value is positive. If the a value was negative, it's going to be a downward facing one. So if it was like this would be y is negative x squared. And then if it's a horizontal parabola, so if it's something like this would be x equals y squared. That would be a horizontal parabola rather than a vertical one. So for these, it's just important to know what does a parabola look like and being able to graph, which you'll be usually given points that you'll be able to, or the vertex, which is it's this one point right here. It can either be the highest point of a parabola if the a value is negative, or it can be the lowest point if the a value is positive. So now let's move on to ellipses or ellipses. They're in the form x minus h squared over a squared plus y minus k squared over b squared equals 1. So what does this all mean? So hk, remember, h comma k, that's going to be your center of the ellipse, similar to how it was in the circle. So this is your center. But what separates this from a circle is this a squared and b squared in the bottom. So basically, if we have an ellipse that is like more horizontally, so it's longer horizontally than it is vertically, this means that our a squared term is bigger because that means it's more in the x direction, it's more horizontally. On the contrary, if we have one that's like this, it's more vertical compared to horizontal, then our b squared is bigger because that shows that the ellipse is more vertical. And this kind of gets you to the idea of like major and minor axes. Basically, your major axis is the side of the ellipse that is longer, so whether that's horizontal or vertical, and then minor axis is the ones that's smaller. I don't really think you need to know those terms. That's more into pre-calculus, but it is good to know. But just remember that it's different from circles because of this a squared and b squared. And depending on which one is bigger, that will dictate how the ellipse is bigger in what particular direction. So if a is bigger, it's greater in the x direction. If b is greater, it's going to be in the y direction. And it is important to note that a is like almost like the radius of the ellipse. So if like this was our center, from here to here, this would be a. So you can figure out the radius of the ellipse almost from, or the length of the major axis from the center to the endpoint by this a squared value. Remember, to find a, you're just taking the square root. And same thing here. You would be able to find b like this, and vice versa. All right, and then hyperbolas are very similar to ellipses. They have basically the same formula, except there's one major difference. And that difference is that there is a minus sign in between the two terms instead of a plus sign. It works in pretty much the same way though. This a will allow you to figure out the length of the hyperbola if it's more in the horizontal or vertical direction, and same thing with the b. Well, a is for horizontal, b is going to be for vertical, and hk is kind of like the center of your hyperbola as well. Okay, moving on to even and odd functions. So even and odd functions, the major thing to know is just what is the difference between them. Even functions, those are functions that can be reflected over the y-axis. So for example, our good old y equals x squared. That is going to be an even function. You can reflect this over and you'll get the same thing. If you're looking at it from an equation-wise, like transformation-wise, f of x is equal to f of negative x. So basically, if you were to plug in negative values for x, you'd get the same function, which makes sense for y equals x squared. So even functions, they're reflected over the x-axis. Odd functions, on the other hand, are reflected if you go from the origin. So you can reflect them at the origin. So y equals x cubed is a great example of that. If we were to flip it, we would reflect it across the origin, you see that we have two equal parts. And in equation form, it would be negative f of x equals f of negative x. So if you were to plug in negative values of x for this function, you'd have to do a reflection over the x-axis to get the correct transformation for it to be an odd function. These are just good to know. They're not 100% required for the ACT math exam, but they are still good to know if you can memorize these. But remember, even functions, you can reflect them over the y-axis, and then odd functions, they're reflected over the origin. All right, and then speaking of reflections, we're going to get to our last topic of function shifts. transformations and translations. So sometimes when you're given functions, you'll have to be able to like translate them and transform them into different places. So we're going to talk about transformations using y equals x squared. So if we're doing a horizontal translation, actually we'll do a vertical one first. That's a little easier to understand. So for vertical transformations, it's like you're adding a number on the outside. So if we do x squared plus 1, it's the same function, except now we're just shifted up 1, right? Plus 1, we're shifted up 1. If we have y is x squared minus 1, same function, but now we are shifted down 1. So that's vertical transformations, just plus 1 going up, minus 1 you're going down. Now for horizontal transformations, it's a little counterintuitive in a way. Because if I give you y is x plus 1 squared, you might think, oh, we're going to the right one. But that's actually not the case here. When you see a plus 1 or a plus constant, you're actually moving to the left. So x plus 1, it'd be like this one. This would be x plus 1, moving to the left one. And then if we're given x minus 1 squared, that basically means we're taking x squared and we're moving it to the right one. So when it's minus, we're moving it to the right. So it'd be like this, for instance. I know it's a lot of graphs here, but it's just kind of to illustrate kind of the point of transformation. So when it's a horizontal transformation, so that means it's inside like the x, right, before the squared. X plus 1, when it's adding, like x plus 1, you're moving it to the left. If it's x minus 1, you're moving it to the right. That's important to know. And then reflections is also a big thing. Just to know for reflections, if you see like f of x, f of negative x, that means you're reflecting over the y-axis. And if you see negative f of x, you're reflecting over the x-axis. So that's also important to know as well. So that's it for coordinate geometry. Those are all the major topics that you guys need to know. Again, this is a pretty important section, especially with these first few topics up here. Those are very important, in addition to also parabolas, hyperbolas, and ellipses. Those are important as well. So make sure you guys understand these topics. Thank you so much for watching. Make sure to leave a like and subscribe, and please let me know if there's anything I can do to help out, if you have any questions or whatnot. Thank you guys so much for watching again, and I will see you all in the next video.